Swayam Prabha. Digital India. Educated India.
Much to dose off. Take your notebook, close it, put it in the bag. Because notebook is here. Done? And put your bag aside. Not hug the bag like this. Nobody will take it. All garbage. No. Huh? How many of you know Tamil? Wow, okay. This is so that Adi Vadara Mari. Okay. Nice to meet you again. We'll have one more session of fun. Okay. I'm given only 2 hours now, which means that cooperation is necessary, number one. I may cut it down here and there, trim it. That's one possibility. The other is, in case we don't finish, I'll come back later, probably a month later, and again engage you. Which one? Okay. So, we have a magnetic personality by name Dharmi and a smart personality by name Hari. Okay, I am struggling between the two. Okay, they are all research scholars in my lab. Our lab is called Active Material Structures and Systems Lab. Don't worry about the name. You make it acronym, it will bring in my initials, a MSS lab. Okay. How shall we start? Game. Oh God. Wait. Indian. Other. Okay. Okay. So we'll start that way. You want it that way. So I need volunteers. Yeah, equally represented between the two genders. 3 plus 3, let us say. 3 plus 3. Frontliners actually don't seem to be frontliners. Oh, here. Okay. 1. I'm going to choose. Come. 1. Name? Ashika. God. Use somebody who is very strong. Very strong. Very strong, huh? Yeah. Strong need not be physical, that's what you're saying. Sorry. 2, name? Pradeepa, AMM. Yeah, good. All right. So, third one. Where do I pick the third one from? Two hands. Nobody wants to be here. Huh? Oh, okay. You want to be. Come. 1, 2, 3. One more from the girls. You self-select. Self-select. Ashika will select. She is self-selected now. Oh, hey, that's not a bad idea. Wow, okay. 1 second. So, you stand that side. Ashika, Pratipa, Sahana. And Akshay, Narendra, and Easy Shreyas. Okay. What shall we ask them to do? What shall we ask them to do? I have all this. What shall we ask them to do? Okay, well, first we'll give, no? One, and then there one, huh? There one, okay. Should I give you one? No, that's enough, sir. You want one? Which one do you want? Which one? Which one? Okay, here. Huh? I gave him something that is. Okay, wait. Sahana, Pratipa, Ashika, Akshay, Narendra, and Shreyas. I want you to pick your favorite. Sahana. Okay, I'll tell you what the exercise is. Exercise is very simple. Exercise could be what? Break it. Okay. Hey, look at this fellows, huh? Shall I use this word thugs? No. 3 puny girls and strong boys. Huh? Okay. All right. So let's pick Sahana. Nobody. At least you have a couple of friends here. Good. Pratipa. Okay, not bad. No. You can't pick too many people. Only one. Okay. Ashika. Ka means like this. Okay, not bad. How about Akshay? That's all, huh? You mean Akshay will win only because of that support only? Okay, Narendra. Okay. Easy, Shreyas. The entire girl population doesn't want to support you. Okay. Who will win? Who will win? You have to pick one of them. Huh? Sahana. Who will win? Easy. Because it's easy for him, no? Okay, shall we start? Right? Now, don't hurt your hand, number 1. Number 2, once you are done, you have to raise your hand so that we know who has come first. Right? 1. At the count of 10. 1, 2, 10. Oh my God. No. You have to break it, yaar. Break it. Oh my God. Break it. Oh God. Oh my God. Ashika. Yeah. Some people are struggling. Come on. Oh my God. Look at that. It's too much here. There were helping hands for Pratibha. Oh God. Hey, what is this, Shreyas? What, Narendra? What's the use of... I was a weightlifter. I couldn't have... finally, give him a hand. Yeah. Now it's a challenge for him. Be careful, yeah. Hey, don't hurt your hand. Okay. And finally, easy becomes very hard for him. You're a good sport here, really. Because losers have to be given hand. Go ahead. The winners have to be appreciated, no? Okay. So who gets the prize? Okay, equally between Shahana and Ashika. Yeah? Okay. Others also, sorry. Volunteers have to get. Yeah. Good dessert after lunch, you know? Yes, here, check. Ah, good catch. All right. Hey, come on here. The puniest of the competitors won. How come?
So you already did something.
She knows, okay. I didn't want to start with the same tearing exercise, so I gave something else. So, what could be the reason? Same material, no? Same rod. Same rod. Okay, examine it. Here. We have enough now, so we can give one. One to each group. One to each group. Ashika is going to distribute. One to each group. Okay, whoever tells me the correct reason for Shahana's win will get a milky bar. We'll give munch. Whoever gives the right answer. One was? Hey, listen to the answer. Perhaps one was hollow. Thank you. You got one? Okay. Perhaps one was hollow. Yeah. Some tape-like thing. No tape-like thing. She is now trying. Oh, broken one. Okay. Yeah, you have. So what? All of them had black. No, all of them had black. No, all of them had black. Huh? Wait. Don't break this one. We'll tell you. Don't break it now. But I need a reason so that you can get your dessert, lunch dessert. Yeah, you have to bend both ways. I'll come to what it means to say that. Point marks. Since the answer is not coming, I'm going to exit. Because I want to go back to the previous one and see if you can answer. I'm sorry, folks. I'm sorry. I made a small blade cut at the center. For Sahana, for Pratipa, and for Rashika. So now they cannot take credits, no? See, so happy. Smile. Look at the smile. But remember the same thing, no? Small defect was enough, right? So I thought somebody would probably come up with that. Okay, so let's learn a little bit about materials. Okay. So where is that? I've been meddling with materials for the past 3 or 4 donkey years and it has been fun, right, Dharmi? See, look at his face. And it is like a wonderland, exploring, keep on exploring. So I'm just going to give a taste of it that I can share with you, okay? That's the motive of the whole thing. Okay. What are the conditions? Number 1. Number 2. Number 3. Willingness to play. Very good. Wow. You remember this at least. Okay. Okay. Game was over. Right? Now, what's the understanding? Right. So, I am going to project the same slide that I projected earlier. Real crystals are never perfect. It's only ideal crystals that are perfect. There will always be some defect or the other. It is like expecting that every one of you secure 100 on 100. That's not possible, no. Right. So, very similarly, for real crystals to be perfect is not possible, which means the defects play a huge role in terms of their failure and strength. Okay. Most atoms are in ideal locations, if you notice carefully, and there are some weak points or points where the atoms are missing, right? Those are the places where you will find that weakness starts to appear and it may grow. And therefore, learning the importance of damage was the one that gave me bread for a very long time, even today. Yeah. Okay, so take this aluminum rod. How many of you have it? You broke also, is it? Okay, I don't have that many. I have only about five of them. You can collect the 5 of them. Okay. Those who have it intact, bend this lightly and leave it. Listen to me, folks, listen. How many of you want to learn about materials? Okay. So, if you want to learn about materials, the way that I learnt it, yeah, what all of them there, is it? Okay. Okay, take this long one, bend it a little bit and leave it. What do you notice? What's your observation? Fun, observation, understanding? Okay, so we are at the observation level. I bend it a little bit and leave it. What happens? It springs back, correct? Yeah? Bend it a little bit more and leave it. Yeah, it doesn't return to its original position, original configuration, correct? Yeah? I'm going to do the same thing on this. How much shall I bend? Huh? It'll come back? Yes. Now, it comes back, correct? And this nature of reversible deformation is called elasticity. Okay? Very loosely, it is called elasticity. Later on, when you study thermodynamics, how many of you studied thermodynamics so far? Oh, you did, is it? It may be just getting to know what is first law, second law, and so on. But there is a lot more to thermodynamics that you will learn. Okay? But just to make it short, it's a deformation that's a reversible deformation. Okay? Under certain conditions of temperature and force. Is this clear? Yeah. And beyond a certain extent, what happens is, it becomes, one is reversible, the other irreversible. Irreversible deformations can occur in 2 ways. The way that you have now noticed is usually termed as plastic deformation. I got my PhD thesis on plastic deformations. All right? What is that? Okay. Let's observe the clay that I used last time. Where is that? The clay. I'm going to do the same thing, which is I bend this a little bit and leave it. What will happen? I need to apply very so slightly, correct? Then I may probably, for example, if I compress this a little bit and leave it, it may probably reverse, correct? But very little. Some of the materials will have more, some of them will have less, right? So there is a limit beyond which it ceases to be having reversible deformation, correct? Beyond which it becomes irreversible. Fantastic. Now this clay is irreversible, add some more conditions. Beyond a particular force, but we also learned something more last time. Pressure, beyond a particular pressure, okay? And what it feels would be stress. So beyond a particular stress, it will give way. Another word for give way? Fail. Oh, another word for give way? Give way. Give way. Yeah. Hello. Okay. Hello. Give way. Give way. Okay. It starts with Y. Yield. Okay. So there is a limit beyond which it yields to, and therefore it's called yield limit. Okay. So every material would have a yield limit. Okay. I'm just starting with all these in a very loose manner. All right. Any questions you may have, you can ask immediately. So clay is mostly irreversible and therefore a plastic material. I'm going to show you another beautiful material. Where is that? Ah, here. Beautiful material. Beautiful material. Not amused, no? Beautiful material, because as I pull and leave it,
Come back to it.
okay, so it comes back, correct? And it is?
Elastic.
I'm going to show you something more. Shall we show this one? Dharmi is going to stretch it and show you here. Oh my God. You can't stretch like mine, yeah. See, look at this. This, if I throw it onto the whiteboard, is nice, no? Because blackboard is gone. Whiteboard, huh? Let's spoil it. Huh? No. Okay. Oh my God. You can see what happens there. Nothing will happen, just pull it. Ah. Ooh, he's struggling. Okay. Oh, not bad. Yes, managed to pull it out. Okay, so look at this. I need to come there and do it. Okay. Is this elastic? Yes. Yes? Look at it. It now wants to come back to its original configuration. When I take it out, just like rubber, it's like loose rubber, right? But yet it is elastic because it is reversible. Same as this, right? These two materials are the same, except the composition varies a little bit here and there. Okay. This material is called septon. Septon, right? It's only sticky, but have a look at it as you feel it and pass it on. Okay. So that's also elastic, correct? Yeah. So one is elastic, the other is plastic or irreversible. Okay. Okay, so I have a question for you. We have now understood elastic and irreversible or plastic. Reversible or elastic or permanent deformation or plastic deformation. Okay. So let's see, examine something more. What is this? A foil. Okay. The Coke can, oh sorry, Coke will get angry. Pepsi can, right? Pepsi can, and where is it? I want to now cut it. I want to cut it. I want to cut it. Why are you keeping quiet? Supposing I ask you to cut a sheet of paper. How will you cut? Cut. So hold a knife. Cut it. Is that what you do? You would keep it on a table and cut so that you can scratch the table. What's the best way you can cut a sheet of paper? If you're asked to bring a tool to cut a sheet of paper, a pair of scissors, correct? A pair of scissors, on the other hand, is easy. That I can just cut. Why is it so? Why is it so? Very good. Opposite directions. Yes. One is going in this direction, the other leg is going in this direction. Okay. Oh, torque, I don't understand at all. Yeah, that's not a torque, that's a force. One force opposite to the other. Okay. I don't know if you have understood, but we are trying to understand. Cutter is one knife, you cut on one side, the other side doesn't get cut.
No, it's an uplinked.
Okay.
This has two things for it.
Yeah.
Hold it under.
Is very small. That's what you want to say. That's what he is also saying. Right? It is like this, and that's what he was saying, on the surface it is gliding. Okay. Anything more? Opposite forces. Good point, but what does that, how do I understand that? If I apply the force on one side, am I audible?
Yeah.
On the video. Am I audible? Okay. You said something. Yeah.
Yes, sir. The force, it just pushes the paper instead of trying to deform it.
Here also, where is that knife? Yeah. Here also it can push the paper.
Yes, sir. But the paper is not giving any resistance to the force.
Okay.
That's
so
only force in one direction.
That's
The
why
paper
you
is
want
not trying to oppose it.
keep it on the table and cut.
Yes, sir.
But it's more comfortable to cut
Hold it on.
using a pair of scissors, no? Supposing I ask you to cut a plastic sheet.
Yes, sir.
On one hand, I have a pair of scissors. On the other, I have a blade. Blade?
No, it's still scissors. Still scissors are required.
How many feel scissors? How many feel this one? You have your notebook, no? So I cut it off from that cover.
Okay,
Scissors, right? Why scissors? Easy. Okay, easy. Shall we try? Huh? It'll work? Yeah, you're right. It's easy. Okay. This is metal. Correct? Scissors. Even for metal. Why here you have preference for scissors? This is elastic. And that's therefore scissors. Huh? He says if it is elastic, use scissors. If it is not, use. So if I have bent this, it is no more elastic. I will use a blade. See, I have bent it, no? So it's not elastic. So I now can use blade. Okay. Yeah.
Becomes, sir, once it becomes plastic, it's not that initial. You gotta consider the initial properties and then.
Any other way of thinking? Because we are seeking to understand, correct? Yeah. Yeah, greater the thickness of the material, greater the force. For example, if I take a thicker one, I have a thicker one. This is thick. This is thick. So what should I do?
Greater pressure, but we can use the same.
What's your name?
Tanusha.
Tanusha has to feel it, then she will tell me what to do.
So is
Okay.
it because of the lever which is helping?
Okay, because of the lever. Any other answer?
So these surfaces are similar. In scissor we apply a couple force on opposite direction.
A couple of forces in the opposite direction is correct.
So more relatives are
A couple of forces in the opposite direction is one way that we have all been thinking. Yeah. Yeah, all of you again, because I'm so forgetful, you may have to tell your name and then.
Sometimes when the scissors, one side of the blade is blunt. Even if one side is sharp, it may not
Correct.
cut properly.
Yeah, but we are seeking to understand why I'm using a pair of scissors which seems to be better than blade. That's the question we are trying to answer.
With scissors, when you do this, you're applying force,
Yeah, that's what I mean. You're coming close. Very good.
force are.
You're coming close.
Sir, so when you take a lighter material, it
Ah.
will have a lighter layer, so therefore it becomes more porous, and therefore we get more defects to cut.
Then you're
When
trying
you
your
take
best.
Very thin layer.
You have tried your best. Good.
So you try to
Name. Ananya.
So when you try to push it from one side, the amount of deformity that we create, when you push it from both sides, the deformity is like more deformity, so it tends to fail faster.
Okay. Of course, we are guessing. Not bad.
Sir, I thought
Name.
Yogita.
Yogita.
So scissor has two sides, so we're disturbing more number of molecules.
Disturbing more number of molecules.
So the defect increases.
So the defect increases. So she has forgot. Yogita says some molecules and pulling. Yes, Shreyas.
Sir, it's like the scissors principle, sir. Scissors, in order to cut, we apply two forces in opposite directions. Two opposite forces we need in order to cut something. So
Why do
in
we need like that?
sir,
Why?
so sir, because if we put just one force, we'll just push it. So we need another thing to
Don't tell me you have never used blade.
Sir, I've used blade, sir, but then the thing is, blade also works on, I think the blade also works on the same principle, sir. So when you use something to cut a blade, you generally use a blade to cut a harder material.
Okay,
This is because a harder material, it's
We'll come to,
tougher to bend.
Fine.
And
Any other answer?
Sir,
You're coming close.
Sir,
Yes, Adu.
in the case of cutting,
In
we
the
need
case of cutting,
molecules from this side and that side have to be attacked. So, when we have on both sides, we penetrate from the top and from the
you're
bottom.
good. I mean, you are now thinking hard, which is very nice. Yeah. Because that's how discoveries are made anyway.
Like another factor,
With proper scientific backing.
another factor could be that you use a blade for thicker materials and rather than using scissors, because you need a lot of force in the table. Like if you keep on a surface and apply it on a blade.
Keep a surface and apply it. Okay.
So when you are using like a circle that's easily
Name.
it's just
Isha.
Okay.
Yeah, Isha. Yeah, go ahead, Isha.
so like
When you are cutting
a surface that's like easily bent.
a surface, you need to use the mic, right? So just pass it on so that, yeah, because they will scold me.
Sir, when you're using to cut a surface that's like easily bendable or like, you know, it's not
Easily bendable.
Yeah. So it's like plastic. And then at that time you need to hold the surface like properly to cut it. So maybe scissors is more effective.
Okay. Give it to him, yeah. Yes, Tanush. Yeah. Correct. That is perfectly all right. I mean, if you have to cut it, you need to find out what the resistance is and apply, definitely.
Sir, I think even when we use a blade, if you keep the paper like this,
Correct.
it will be easy for the blade to cut.
Yeah, but
So
I can use
scissors-
it that way, no.
Huh?
I can use it that way. Why am I coming up with this tool called a pair of scissors? That's the question, no? Scissors is easy, correct? Amplified, not really, no. It's the same sharp edge. No, I'm looking for an understanding, which is an understanding. See, for example, when we discovered that if there is a defect, the material is bound to fail easily, correct? That's an understanding. Now, we are now comparing two scenarios where I use a blade or a pair of scissors. And I'm finding that the pair of scissors is easy to cut a sheet of paper or a plastic or a thin sheet of metal.
Sir, if it's a paper, the thickness is very less, so my area is less. That means I'll apply more pressure if I use a blade that could damage the material. Yes, I want to cut the material, but that could also damage it, because if I keep a paper straight, I could end up folding it.
So, I take a sheet of glass. Scissors. See, all are laughing. Because you have the experience, of course, yes. Glass, pair of scissors, doesn't work, no? Doesn't work. Yeah, it's similar to glass. The one on your cell phone, no? Tempered glass. That can be cut? That can be cut? No. It cannot be cut. Okay, so the way I understand is like this. I'm just going to start and see how far you can catch it. All materials are made of atoms or molecules, correct?